Hello, good evening. We're going to go over 5-2, which is what we talked about in class today, the macro anatomy of a skeletal muscle. So there's only 2 slides and a couple of pictures on here, but I know some of you guys like it, so you can screenshot it and print it out because you're lazy. So let's take a look at a skeletal muscle. So we said that each skeletal muscle is an organ itself made up of several kinds of tissues. Of course, there's muscle tissue, but there's also connective tissue, fat tissue, and other items, vascular tissue as well. So each organ, or each muscle, is its own organ. So however many muscles you have, that's how many organs you have. Each muscle has its own nerve, an artery, and several veins. So if I take a look and draw one muscle, like that, there's going to be an artery that goes in, like that. There's going to be a nerve that goes in, and then there's going to be several veins that come out, and they all go in through one particular port. And so it's kind of like the nutrient form in the bone. It goes in, and then from there it spreads out and takes care of the whole entire muscle. Now the muscle itself, if I were to take it and chop it in half and look at it on end, what we would see is that there's big circles in it, kind of like a pomegranate. That's what it looks like to me. And then inside, even smaller circles in there. So a muscle is made up of several different structures. So we're going to look at each one. First one is called the endomysium. Endomysium is what surrounds an actual muscle cell. So a muscle cell is very long, like this, and they call it a fiber because it's actually a collection of lots of different cells all smushed together. And so surrounding the outside of this cell is the endomysium. So endo, inside, mys, muscle. And so those are going to be surrounding each individual little cell, which is kind of hard to draw with this little thing here. And then we have the paramecium. Peri means around, and the paramecium is going to be what surrounds each bundle and kind of is all in between here. So each little bundle, the bundle, by the way, I mentioned it, but I don't see it written. Oh, there it is, duh, right there. The bundles are called fascicles because if you remember, the root word fasci means bundle. And so the fascicles are going to be wrapped around with paramecium. And then around that, we're going to have something holding it all together with it, which is the epimysium, which goes around and holds the whole entire muscle together. So all these mysiums are connective tissue whose job it is to kind of keep everything compact and close together. So if you eat steak, you see these things. When you look at a cross-section of your steak, you can actually see all these individual little bundles. Okay, so connective tissue, and they surround different parts of the muscle. Now today I used a collection of pencils to kind of illustrate it. So the pencil, I said, was one of these things. And so a pencil is the fiber cell, and it is the pencil's covered in yellow paint. So we pretended that the yellow paint was the endomysium. So that would all be inside of here. And then I surrounded it with Scotch tape, and the Scotch tape would be the paramecium that wraps around each bundle. Okay, and so we would see that in between there. And then we have the paramecium, which goes around the whole entire thing, and it's also this too. And it goes around and wraps and kind of holds together the whole muscle. So on this cross section over here, we've got the orange, the epimysium. We've got the blue, which is the paramecium. And then we have the yellow, which is the endomysium around there. And those are all your mysiums. Okay, then we talked about muscles and how they attach. So if this is your arm bone, this is your humerus. That's a humerus. That's the other end of the humerus. Never mind, that looks really bad. Let me try again. I'm just going to do that. So if these are the 2 muscles, or the 2 bones, your muscle will be fixed and stationary to one bone, but will attach to another bone and causes it to move. So here's your biceps right here. So the area where it's attached to the bone that moves, because if you shorten this muscle, this bone will come up, we call that the insertion. So right there, that's the insertion. Where it's attached to the bone that doesn't move, we call that the origin. The origin is typically closer to the middle line of the body, so it's proximal. The insertion is usually farther away. This is your hand right there, 5 fingers. And so insertions are usually distal. Now, how the muscle attaches to the bone will determine what type of attachment it has. If the muscle is attached to the bone directly, then, well, we call that a direct attachment. And so the muscle will actually be directly connected to the bone. If it's an indirect attachment, then what happens is I've got my muscle, and it'll be attached to the bone, but then it stops short of the other bone and turns into a tendon. And so we call that an indirect attachment because the muscle is indirectly attached to the bone. And then we have aponeuroses, which is where the I'm trying to think of an easy one. So if I have a muscle that needs to attach over here, it might do so in a big sheet like this. And that sheet is still connective tissue, like a tendon, but it's flat. So we call it an aponeurosis. If I'm talking about a whole bunch of them, then it's aponeuroses with an E instead of an I. So on this picture here, that'll show you the aponeurosis right here. Shows you an indirect attachment with the tendon of this muscle to that bone. I just don't have a picture of an actual direct attachment. Okay, so that's all we talked about today. So print this out to your heart's desire. See you tomorrow.